So in section 1.2, we did absolute value. In section 1.3, we did inequalities. In section 1.4, we put those two together and we do a topic called absolute value inequalities. Imagine the two together. How do they relate to each other? That's what we're going to be looking at in section 1.4. Okay, let's take an example. Well, actually, there are two parts. There are two things that could occur. Either the absolute value of x could be greater than or equal to 3, or the absolute value of x could be less than or equal to 7. For example, now the best way of trying to, so let's forget that for a minute. Let's just look at this. The best way of trying to figure this out is to draw a number line that had everything. So in other words, 1, 2, 3, infinity, -1, -2, -3, -4, -5, infinity. I'm sorry about that, in case you started doing that. Okay, so let's see if we can figure out what this is. So obviously the key number here is a 3. Well, let's substitute values for x and see what it looks like. So you could see that when x is equal to 3, 3 is good because 3 is equal to 3. So that's going to be part of the solution, right? Now, +4. The absolute value of +4 is 4. Is 4 greater than 3? Yes, that is. So everything, it looks like everything greater than 3 because 5 is included. 5 is greater than 3. 6 is greater than, this is what it's going to be. It's going to be everything going in this direction, all the way out there. But you also have to take into account the fact that since it's absolute value, when we start at -3, the absolute value of -3 is 3. 3 is certainly equal to 3, so that's included. -4, the absolute value of -4 is equal to 4. 4 is greater than or equal to -3. So it looks like the values would also go in this direction. X could be less than or equal to -3. In other words, going this way. Or X could be greater than or equal to +3. That's the solution. X is less than or equal to -3, greater than or equal to +3. Or, it's an or. Very, very important. And using interval notation, it will be -infinity to -3 or +3 to infinity. So first of all, we drew a number line. And we started at 0 here, and we put in a lot of numbers going all the way to infinity. And then in the other direction, going to -infinity. And then I said the best way of trying to come to grips with this, which was true, is to substitute values, starting with 3. So we put in 3, that was included, because 3 is equal to 3. We put in 4. The absolute value of +4 is 4. 4 is definitely greater than 3. 5. The absolute value of +5 is greater than 3. It appears that one part of the solution will be from 3 going all the way out to infinity. and going in the other direction. And then, if you took points in the middle, it's not going to work because two is not greater than 3, 1 is not greater than 3, 0 is not greater than 3. Nothing is greater than or equal to 3 unless we go all the way over here to -3. The absolute value of -3 is 3, which is certainly equal to 3, -4, which is certainly greater than 3, and so on. So the solution is everything going in this direction, starting at -3, everything going in the other direction, starting with +3. So x is less than or equal to -3 is one part of the solution. Here, this is what it equals. And this represents this. And an interval notation, it'll be from -infinity to -3, inclusive of -3, so brackets, but or, because they're going in opposite directions, so it's impossible for a value of -4 to be greater than 3 and less than 3 at the same time. So there it is. There it is there, and there it is there. It's everything either less than or equal to -3, greater than or equal to +3. It's an or situation. Now here, what does this look like? Well, -infinity, 0, +infinity, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, -7. Let's see what happens. So 7 works, right? Because x is equal to 7. 6 will work because 6 is the absolute value of 6 is less than 7. Everything in this direction. 0 is definitely less than 7. -3 is less than 7. -4 is less than 7. Going all the way out here to -7. Because the absolute value of -7 is 7, and 7 is definitely equal to 7. However, everything over there won't work, like 8. Because the absolute value of +8 is 8, which is not less than 7. So anything greater than 7 is not going to work. Everything less than -7 is not going to work. Therefore, this represents the solution. And an interval notation, it will be 7, whoops. 7 negative to 7 positive. And that's it. And this is an and situation. This is an or situation. The rule: when the absolute value of x is greater than or equal to some value a, then x is greater than a, or x is less than or equal to, greater than or equal to a, less than or equal to -a. There it is right there. X is less than -3, greater than 3. If it's a or any value, it could be 4 or 5 or 6, then x is less than or equal to -a, or greater than or equal to +a. And here, it's going to be x greater than negative a and x less than or equal to a. So this is an and situation, and this is an or situation. And we could even go further and express this in interval notation to state that this is going to be negative infinity to negative a, and let's use brackets, or from a to infinity. And that's what we had right up here. Negative infinity to the negative value of 3, a to infinity, 3 to infinity for the other direction. And this one would be negative a to a. That's the generalization, which would be the rule for this type of situation. I'm sorry it's confusing. I always apologize when things seem a little difficult. Let's take one of each. Let's take one of each as an example. For example, the absolute value of x is greater than or equal to 2. Graph that with the interval notation, and also this one. The absolute value of x is less than or equal to 9. Okay, so exactly what we did here, do for these two examples on your own. Well, this shouldn't take you long, because if you draw the number line, first of all, you know that a greater than sign means or. Or will always mean going in opposite directions. So here's 0, here's 2, here's negative 2. So this is going to be from here going in this direction with a shaded in circle because there's a line underneath. This line means, shaded in circle. And then going in the opposite direction, again, shaded in, it'll go out here. The greater than means opposite directions. You can write that down. The greater than means opposite directions. And in interval notation, negative infinity to negative 2, or positive 2 to positive infinity. And this always means opposite directions.
Can you move the screen down a little bit, please?
Oh, yeah. Oh, yeah.
Thank you.
Thank you for telling me. Thank you. Thank you. I'm trying to keep everything on the board, it's just not, you can't do that online. You could do that in the classroom, but you can't do it on, on an online situation. That's one of the drawbacks. This one is the and situation, which means that here's the number line, here's 0, negative infinity, infinity, 9, negative 9. And that's what the rule tells us. The rule tells us that if x is less than or equal to a, it will be less than or equal to A, greater than or equal to negative A. So this is what it looks like. And when it's less than, it's an and situation between or opposite directions. In this case, it's and in between. Between. That's a good way of, the generalization. The greater than sign, opposite directions. The less than sign, in between. And the way you would write this is -9 to 9. And there it is. Those are the two solutions right there. See, this requires studying. You need to really, after class, do the homework, study this. I mean, if somebody gets this from just what I did here, that's wonderful. But if it, for most people, it's not. It doesn't happen so quickly. Didn't happen for me like that when I was in college, that's for sure. But there will be a video, and that will, you could go over the whole thing if you want. Can anybody think of a question? Just remember, greater than, opposite directions. Less than, in between. And these are these are two beautiful examples right here. This summarizes everything we just did up above over the past 20 minutes. And if there are no questions, I'd like to give you two problems to try. Okay. So we're going back up on top. And I'm going to keep all this stuff and just erase this stuff here. And leave that, actually, the example, and then just give you two problems to try. And let's see how you do. So these will be a little more elaborate, obviously. The absolute value of A plus 9 greater than or equal to 6. But I don't want to give you any, hints. So I'm not going to give you the hint. And this is x minus 5 less than 3. Okay, do those two problems. Let me begin doing this. So this is how you would do it. This is an or situation, which means that the solutions go in opposite directions. In other words, A plus 9 will be greater than or equal to 6. That's one branch of this. Or A plus 9 will be less than or equal to -6. That's how you would start this problem. And let's continue solving. -9, -9. A is less than or equal to -15, or the big or, and let's do this one as well. A is greater than or equal to -3. So here are the two points. Either this will occur or this will occur. But if you're having trouble visualizing it, then take a number line Now, we're not gonna need positive numbers, so we could put the 0 there, the -3 there, the -15 there, negative infinity, and infinity. One solution will be A is greater than or equal to -3, going here. This will be A is less than or equal to -15, and that would be looking like that. So this is what we did. It was a little more elaborate than the previous problems were, but the concept was the same. Everything in the absolute value will either be greater than 6 or less than or equal to -6. And there's the two parts. And in interval notation, it'll be -infinity to -15 or -3 to infinity. There's the complete problem. And I just want you to look at that and focus on it. And now let's go over here. This is the and situation. In other words, coming together so that x minus 5 is less than 3, but at the same time greater than -3. And you could put them together actually, because you know that it's going to be in the middle. You have to put these separately because they're going to be going in opposite directions. But this you could set up as the and situation. And you just solve it. Remember when we solved it earlier? +5. That drops out. The x is remaining. The two symbols here. This is 8 and this is 2. And there's a solution. And on a number line, here's 0. We're only talking about positive numbers. So we could do this. And it's everything in between. And in interval notation, it will be 2 and 8. And that's it. That's a complete problem. One of these is on the first test. I don't even know which one is which. One of them is on the practice test that I'll be giving you, either the end of this week or the beginning of next week. The practice test is going to parallel what the actual test will look like. So one of them will be on the practice test, and the one that's not on the practice test is going to be the one that's on the test probably. But these are the two possible questions that could be asked.
I have a question.
Oh, thank goodness. Okay,
Um,
Hayatu, go.
Yes, for the second one, the one you did now. So can we do it to the same way like we did for the first one?
Like this? You mean separate the two, separate the two. In other words, don't put them together? Is that what you're saying?
Yeah, if we can do it like the same way. Oh,
You mean x plus 5 is greater than -3 and x plus 5 is less than 3. Is that what you mean?
yes.
Yes, you could do it that way. That's the way we originally solved this in the previous chapter. Previous section. And then I put them together.
Okay, thank you.
You're welcome. Oh, we're back up to 24. Okay. Can we do one more? Yes. I think we should do one more. So,
Yeah.
Yes.
yes, yes. Let's do one more. I mean, this time we did both, so you knew that, you know, both situations were taken into account. But, I mean, if you're just looking, if you're taking a test, you're not gonna see the solutions, so let's. So it would, the instructions would be solve for, I like X, solve for X, express the answer using a number line and interval notation. Interval notation. And here's the problem. The absolute value of X minus 4 is greater than 2. Okay. I'll leave it to you.
Professor,
Yes.
does it matter if the variable is different? Or if it's A or X, we still solve the
No,
same, right?
no, the variable is completely and totally irrelevant.
Okay.
A, X, Y, Z. I'm starting you off. X minus 4 is greater than 2. X minus 4 is less than negative 2. That's the beginning. That's the rule. One of them is greater than 2. You know, the way I remember this when I first learned this was one of them is exactly the same. This one is just exactly the same, and the other one is less than negative 2. Just have to remember this one. And think of, and remember that when it's greater than, they're going in opposite directions. So one of them is going to be less than, one of them is going to be greater than, because they're going in opposite directions. I just solved both of those inequalities the way, you know, we're used to solving it. And on a number line, we could put the 0 over here, negative infinity, infinity. We need a 2, we need a 6. They both have no line underneath, so they're both going to be open circles. And x is less than 2, so it's going to go in this direction. X is greater than 6, so it goes in this direction. That's what it looks like. That's what's intended by the greater than sign. And in interval notation, negative infinity to 2 or 6 to infinity. Are there any questions?
Does it matter based on the structure of it? Because I had the positive on the left hand and the negative on
No,
the right.
no. In other words, you have this over here. and
Yeah,
you
that's
have
correct.
This over there. No, it doesn't matter.
Okay.
Absolutely not. As long as it translates into a number line that looks, because I'm just asking you to express the answer using a number line and interval notation. I'm not asking you, you know, how you solved it. You can solve it mentally if you want. But this is what I'm looking for. I'm looking for this number line here and this interval notation here. That's what I'm looking for. And this is a possible test question. This is how it'll look. Not more difficult than this. or it will possibly be a less than situation. It could possibly be a less than situation, like the absolute value of x minus 4 is less than 2. That's another possibility. You want to try that?
Yes, Professor, because I'm a little bit confused.
Oh, just a little?
Yeah, because I would like to know, like, if we have the greater sign, so it means the solution is our solution. And if we have a less sign, we have like an n solution.
Well, I didn't understand what you said, but I will say that if it's greater than, they go in opposite directions. If it's less than, they're between two numbers. Like I would go from here to here. This first transition is very, very important. And that's what I would do. I would go from here to here and from here to here and say that these are very important. So that's what I would do in this situation. And I'll let you finish it from there on. So this is what I'm doing. See, I put them together at the beginning rather than worrying about putting them together later. This is, you know, from here, you just work it out like this. There it is. That's it. And in a number line, it will be 0, 2, 6, open circles, and in between. And in interval notation, this is what it would look like. That's it. Notice the difference. If it's an or, you're going to have two situations going on. One here, one there, one here, one there, one here, one there. That's an or. If it's and, if it's less than, it's and. So I put them together. I solved it. And there it is, like it's between the two values. And it'll be a very simple interval notation.